Calculation number 4. So here we have a poll back in the day between Barack Obama and John McCain. And we see we have women's vote, and it's broken down among all women, white women, and suburban women. And this is a poll that was conducted in June, which we see is before the election day, which is in November. So this is a poll of likely voters, likely women voters, and who they were going to vote for. So the question is, did McCain have a significantly higher percentage of the vote compared to Obama among suburban women? So we see that Obama had 38% of the suburban women's vote, whereas McCain had 44% of the suburban women vote. I want to know, did McCain have a significantly higher percent of the vote among this sample of women? See if you can work through this problem and see if you can answer yes or no and justify using the data. Okay, so let's see if you're able to work through it. So this one can be a little tricky. So if we take a look at the poll, and we see we have some information. Obviously, we have the percentage vote for each of these three groups for each candidate. But take a look here. This 3.1%. This is our margin of error. Notice there's a plus and minus in front of it. So this is the margin of error. The 38% for Obama and the 44% for McCain would be our point estimate. So knowing that we have the point estimate and we have a margin of error, what can we then figure out? We can really figure out the confidence interval of where we really think the suburban women are going to vote for Obama and McCain, given the margin of error. So let's figure that out. For McCain, we have a confidence interval of 40.9 and 47.1. As we see, we have the point estimate of 44% of the suburban women vote with a margin of error of 3.1. And what about Obama? Well, he has a point estimate of 38% plus or minus the margin of error, which is 3.1, gives him a confidence interval of 34.9 and 41.1. So now that we know the confidence intervals for both Obama and McCain, we want to know, did McCain have a significantly higher percent of the vote? Well, we see that McCain has a vote anywhere between 40.9 to 47.1, whereas Obama, he has a vote as low as 34.9 or as high as 41.1. So thinking about this, no, McCain does not have a significantly higher percent of the suburban women vote. So even though McCain had a higher vote percent, 44, compared to Obama's 38%, McCain's confidence interval overlapped with Obama's confidence interval. Look at the lower limit of McCain and the upper limit for Obama. Notice that they overlap. Because they overlap, we say that McCain did not earn significantly higher because it's not true. He could earn as low as 40.9 and Obama could earn as high as 41.1, and if that is the true case, then Obama really wins, and McCain doesn't. So this means that there was at least some small chance that in the population, Obama might even have won the vote among suburban women. Alright, so let's take a visual inspection of what we saw in the previous slide. So here we have a poll again between McCain and Obama. And this shows polls from different media outlets such as CBS New York Times, LA Times Bloomberg, ABC News Washington Post, so on and so forth. So the questions: does McCain or Obama have a solid lead over the other, or is it a close contest? According to the LA Times Bloomberg poll, the Gallup poll, and the Rasmussen Daily Tracking poll. For each of these three media outlet polls, figure out if McCain or Obama has a solid lead or if it's a close contest between the two. Okay, so let's see if we were able to figure out if there was a solid lead between McCain or Obama, or if it was too close to call. So the LA Times and Bloomberg, we take a look here, we see McCain at a point estimate maybe about 41, lower limit as far as maybe 38, and an upper limit as high as 44, whereas Obama has about 50% of the vote, plus or minus, we can see, maybe as down as 47 and as high as maybe 53. So given this, Obama has a solid lead over McCain. There's no overlap of their confidence intervals. What about the Gallup poll? Well, we see an overlap, so there's a close contest. We really don't know who's going to win and who's going to lose. And what about the Rasmussen? Looking carefully and closely at this one. Well, can't really tell based on this poll, so Obama looks like it has a lead over McCain, but it's pretty close, so we really don't know. Maybe it's a close contest? So again, hopefully you can see visually the idea of winning a vote in terms of taking into account the margin of error and your confidence interval. Okay, so click on the image under this link to watch a cartoon reinforcing concepts about confidence intervals. Alright, so to summarize, type 1 errors, also known as our alpha level or a significance level, are committed when you reject the null when in fact it's true in reality. While type 2 errors, or beta, are committed when you fail to reject the null when the alternative is in fact true. And so some common alpha levels or significance levels that we see in research, 0.05 and 0.01. The steps that we're going to take for hypothesis testing are, first, stating the null hypothesis and the equation. Second, stating the alternative hypothesis in the equation. Step 3, calculating the test statistic. Step 4, making a decision. And then step 5, stating your conclusions. And then lastly, the idea of confidence intervals. And these provide a range of values around a statistic, such as the mean, that are believed to contain, with a certain probability, the true value of that statistic within the population, which is then your parameter. And here we have the equation for confidence interval, where the mean plus or minus your z-score, which is based upon your confidence interval, times your standard error of the mean, which is your standard deviation divided by the square root of your sample size. And then lastly, our table of figuring out which statistical tests do we run based upon our independent and our dependent variable. When we're doing difference tests, this is when we're looking at differences between groups and categories. So we have nominal or ordinal variables. And depending upon our outcome, our dependent variable, if we're looking at differences between groups on different outcomes, different groups, we're doing a chi-square analysis. If our outcome of our dependent variable is a numerical value, where we can calculate a mean and standard deviation for an ordinal variable or an interval or ratio variable, then we're going to conduct a dependent samples t-test or paired samples t-test if it's one sample and we're looking at before and after an intervention, or if we have two different groups like males and females, or those who eat fast food regularly and those who do not eat fast food regularly. We're going to conduct an independent samples t-test. And if we have 3 or more groups that we're trying to compare on some outcome that has a mean, we're then going to conduct a one-way ANOVA, which is an F-test. And then if we're looking at relationships between two variables, and those two variables have means, then we're going to conduct a Pearson's correlation coefficient.